This video will take us through Chapter 24, Comparing Means, the hypothesis test. How does smoking affect heart rate? That's the problem that we will be working on to learn this new test. We have a random sample of 26 smokers and 32 non-smokers. The average heart rate for the smokers was 80 beats per minute with a standard deviation of 5 beats per minute. And the average heart rate for the non-smokers was 74 beats per minute with a standard deviation of 6. The distributions of both samples were unimodal and roughly symmetric with no outliers. And we want to find out if there is a difference in the average heart rate between smokers and non-smokers. All right, so in order to begin this problem, we need to state our null and alternative hypotheses. All right, so clearly now we are dealing with means like we were in the last unit, but we're now dealing with two means. All right, so just like in previously when we were doing proportions, when we compared two proportions, this is going to look very similar. All right, so our null hypothesis should be that there is no difference between the heart rates of smokers and non-smokers. So we're going to say that the mean for smokers minus the mean for non-smokers is equal to 0. All right, so remember that's basically the same thing as saying the mean for smokers is equal to the mean for non-smokers. So we're skeptical. We think that they're exactly the same. Then the alternative hypothesis is that the mean for smokers minus the mean for non-smokers is in this case not equal to 0. Because remember, up here we were looking for whether there is a difference. Not specifically what kind of a difference, but whether there was a difference. All right, so then we're going to move on to our conditions and assumptions, and these will be very similar to the ones that we had when we were just dealing with one mean, except we're going to have to prove them to be true for both. All right, so first, we were told that we have a random sample of 26 smokers and 32 non-smokers. Okay, so we're going to say smokers and non-smokers were chosen randomly. All right, and to establish independence within each of the groups, we would want to make sure that the group of 26 and the group of 32 smokers versus non-smokers were less than 10% of their respective populations. So we're going to do those separately. We're going to say 26, I think it's reasonable to say, is less than 10% of all smokers. And that 32 is less than 10% of all non-smokers. And this problem is slightly different from the problem that we did when we were doing a one sample test for means, because there we had data. Here we don't. We have the statistics to begin with. All right, so if we're looking at our statistics, we don't have anything to graph. So we can't actually prove that the distributions of our samples are normal, but we were told in the problem that the distributions of both samples were unimodal and roughly symmetric. So we can say that both samples are approximately normally distributed. Okay, and then in this case, because we have no data to deal with, we have no graph to create. All right, and we have one final condition, which is new for this, and it's similar to the condition that we had when we were comparing two proportions. We just have to make sure that the two groups that we're comparing are independent of one another. Okay, so we must assume in this case that there's no reason that the smokers and the non-smokers outcomes were reliant on one another. Okay, so we can assume the smokers and non-smokers are independent of one another. All right, so our conditions are met, and so we are ready to move on with the problem. So moving down to mechanics. All right, so the test that we're going to be doing this time is a 2-sample t-test. All right, and we're going to use because our conditions were met, we're going to use the t-distribution again. Because in this situation, again, we don't know the standard deviation for the population. We're going to be estimating that, which means we use the t-model. So we're basically going to be using the t-model anytime we're talking about means. All right, anytime we're talking about proportions, we're using the normal model. All right, so let's reiterate and list our statistics that we were given. We were given the sample for non-smokers to be 26, the sample mean for smokers to be 80, and the sample standard deviation for smokers to be 5. And for non-smokers, we had 32 of them. Their average heart rate was 74, and the standard deviation for them was 6. Okay, so it's good practice to list these out. And we are interested in y bar s minus y bar n, the difference between the two. And in our case, the difference between them, 80 minus 74, is 6. Okay, so that's our statistic in this case, and we also need to calculate the standard error. So again, this is standard error because we have to approximate it with our sample standard deviation. So, and we have two different distributions that we're putting together here. We're putting together the distribution for means for smokers and the distribution for means for non-smokers. So going back to an earlier unit, we're unsure about the distribution for smokers, we're unsure about the distribution for non-smokers. So when we do that and we put them together, we have to add their variances. So that looks like taking the standard deviation for smokers, which would be the standard deviation divided by square root of n, and then squaring that to get variance, plus the standard deviation for non-smokers over the square root of n for non-smokers, squaring that, and taking the square root of the entire thing. All right, so you need to make sure that you show this formula on your papers and that you actually calculate this value out. So you might want to take a minute to do that right now. And once you've gotten your calculation down, you should find that it's 1.44. All right, so now we're ready to move on and say we are looking at a t-distribution with now 56 degrees of freedom. All right, so now here's the deal. I'm going to go down to the notes section and talk about degrees of freedom for a second. When we're dealing with two samples, instead of subtracting one like we did for a one sample, we're going to subtract 2. All right, so we're getting our degrees of freedom by taking n minus 2, and that's because we were doing a 2-sample test. For a 1-sample test, it was n minus 1. For a 2-sample test, it's n minus 2. I think that makes reasonable sense. Okay, for as much sense right now as degrees of freedom makes. Okay, so we're looking at the t-distribution with 56 degrees of freedom, centered at 0, because we assumed there was no difference, with a standard error of 1.44. And then we're going to compare our difference, which was 6, okay, and to get our p-value. But remember, we're also doing a two-tailed test here, so whatever our answer is, we're going to double it, because even though now we know that the smokers' heart rate is higher for our samples than the non-smokers, what we initially cared about, if you go back to your null and alternative hypothesis, we just cared about them being different from one another. So this is a two-tailed test. So we're going to calculate our t-score by taking 6 minus 0 over 1.44, and we will get a t-score of 4.15. And then to get our p-value, that's the probability of being above 1 or being 4.15 standard deviations above the mean or below. All right, so to do that on our calculators, we are going to go to second distribution, and we want TCDF, so that's number 5, and we want to go from 4.15 standard deviations above the mean to some large number. And remember, we also have to put in our degrees of freedom, which is 56. All right, so we get 5.71 times 10 to the negative 5, which is approximately 0. But just to be clear, this area right here is the 5.71 times 10 to the negative 5. And we would double it to get both. So we're taking, you don't necessarily need to write this on your paper, but just so you're clear, 5.71 times 10 to the negative 5, and we are doubling it because we're doing a two-tailed test. Okay, but either way, that is approximately 0. All right, so now we're ready to make our conclusion. We have an extremely low p-value. So just like all of our other tests, due to a low p-value, I'm going to say due to a low p-value of 0, or approximately 0, we reject the null hypothesis. There is strong evidence to claim, and this is where we make our comment on the alternative. So no matter what you decide, you're always commenting on the alternative. In this case, because we rejected, we get to say that there's strong evidence to claim that the alternative hypothesis is true. There's strong evidence to claim that there is a difference in the heart rates of smokers and non-smokers. Okay, so the new things that we have here, as far as this test goes, compared to the one sample test, we have an additional condition that we're dealing with, and when we're doing our calculation of standard error, we have to remember that we are adding variances. All right, and then our degrees of freedom change slightly because we're taking n-2 as opposed to n-1. Otherwise, this should look very similar to the other tests that you have done. So now I'll quickly show you how you would do this in your calculator and not do each of these individual parts out on their own. So you're going to go to Stat, Tests, and you want a 2-sample t-test. And instead of data this time, we have stats. So we're going to put in for our x bar 1, 80. You could do it in reverse if you wanted, but I'm going to put in 80, and my standard deviation is 5, and my n is 26. So that's all my smoking data, or my smoker data. And then for non-smokers, we have 74 for our mean, standard deviation of 6, sample size of 32, and we were interested in there being a difference, so not equal to each other. And here they're asking for pool. That's not something we talked about, but we did talk about when we were doing 2 samples before. We're never going to pool for a 2-sample t-test. Your book talks a little bit about pooling, and there is the opportunity to do that in certain situations. But remember why we pooled before. Before we pooled because we were assuming there was no difference between the two proportions, and then when we were calculating our standard error, we had to use proportion in there. Okay, and so since we were assuming the proportions to be the same, we made them the same by pooling. We don't have the same situation here. We have no reason to assume that the standard deviation for smokers should be the same as the standard deviation for non-smokers. So we have no issue. So we're not going to pool, and we're going to just say calculate. And hopefully we get all the same values that we had before. We have our t-value, or a t-score, to be 4.15, which is what we found. Our p-value to be some teeny tiny number, approximately 0, which is also what we found. And you'll notice that your calculator is using 55.95 degrees of freedom. All right, there is a way to calculate degrees of freedom on your calculator, and in the future you can just read this right off your calculator. Rule of thumb is to subtract 2 when you're doing a 2-sample test, but you may also just copy the value that your calculator comes up with. Notice it's very, very close to what you guys had. All right, so we have all the same values that we came up with before. So now you know how to do a 2-sample t-test for means, both by hand and on your calculator.